In this video, we're going to talk about the equation of circles, or any circle to be specific. Now, a circle is a very specific type of ellipse. So the circle and ellipse equations, which we'll get into ellipses soon, but the circle and ellipse equations are very, very similar. There's just one subtle difference. So let's ensure that we understand the definition of a circle before we deal with ellipses. A circle is the set of all points in a plane that are all equidistant or a fixed distance, measuring the radius length, from a fixed point, center, in the plane. So when we talk about this center and radius, we're going to use HK for our center and R to represent the radius. And the equation would be X minus H, quantity squared, plus Y minus K, quantity squared, equals R squared. Now, you should be mildly familiar with the equation of a circle at this point. We are going to not really focus on the fact that we could have a circle centered at the origin 0, 0, but you could see very easily if we plug in 0 for H and 0 for K, we would get this more abbreviated form for our definition. The main thing we want to know about recognizing a circle is that a circle, as well as an ellipse and a hyperbola, have both an x squared and a y squared. The difference between a circle and an ellipse is that a circle is just a very specific type of ellipse where the coefficients are the same. So for a circle, the coefficient in front of both my x squared and y squared terms would be identical, and the signs would have a positive and a positive. It is possible to have a negative and a negative here, and we could isolate that on the other side by factoring out a GCF. But the main idea is both x squared and y squared, both the same coefficient in front of your squared term, and then they both have the same sign, so either both positive or both negative. All right, let's do an example. For this example, we're going to identify the conic and then state its attributes and sketch the graph. Obviously, we know we're dealing with a circle at this point because I just defined a circle for you. But what we do is we come over here and we look at our squared terms. If we have both x squared and y squared, that means it's not a parabola. So then, as I previously mentioned, we look at both the x squared and the y squared term. They are both plus plus. They both have coefficients of 1 and 1. So same signs indicates that we are dealing with either a circle or an ellipse. All right, so the same signs indicates we're dealing with a circle or an ellipse. So we know it is not a hyperbola. Hyperbola, x squared and y squared terms would have different signs. We could have a plus or a minus here. And then we see that they have the same coefficient. Having the same coefficient means that it is a circle, not an ellipse. Ellipse will have different coefficients. So this is kind of the run through. I'm looking at, again, x squared or y squared. Do they have the same signs? Do they have the same coefficient? So all those things help me to determine and narrow down what type of shape I'm dealing with. We know this is a circle, 1, because this video was about circles, and then 2, because of these reasons that I've discussed here. And again, we'll continue to discuss these reasons as we move through our conics section. So we've identified that it is a circle for sure because of all of those attributes. Let's put this into standard form. So in order to do this, we have 2 squared terms. I'm going to need to complete the square twice. So I'm organizing this in such a fashion that I've got my x squared an x term plus some magic x value. And I have my y squared, so I've got y squared, and that would be plus 14y, plus again some magic value, and that's going to equal negative 32. And whatever these values are that we add on the left, we must add those same values over here on the right. So I like to go ahead and, write my spaces for where I know I'm going to be plugging a number in. At this point, we go to complete the square. We verify that both of these have a positive 1 leading coefficient. Both my x squared and y squared terms have positive 1 leading coefficients, which means that I do not need to factor out a GCF. So I'm going to run through my same pattern, which is going to be b divided by 2 quantity squared. Here I have negative 16 divided by 2 squared, which is negative 8 squared, which means I'm adding 64. So I'll go ahead and put my 64 on both sides of the equation. And then I have 14 divided by 2 squared, which is 7 squared. That should be an equal, not a plus. We've got equal. 7 squared equals 49. So now I add 49 to both sides of the equation. What this does, this allows me to write this as x minus 8 quantity squared plus y, and that's a positive 7 that we squared, so plus 7 quantity squared. And that's equal to 81. So when you get to this step, if this isn't a perfect square number, you probably, more than likely, did something incorrect. So most of the questions that you guys work on in your homework, they should work out rather nicely. You're not going to get crazy numbers here that are difficult to deal with. So this should always be a number that I can take the square root of. So this is a circle in standard form. I'll just rewrite this. 8 minus x squared plus y plus 7 squared, and the square root of 81 gives us 9 squared. Therefore, we know the center is at positive 8, negative 7, and my radius, r, is equal to the square root of 81, or 9. If I wanted to graph this, it would look like, well, I would go over positive 8 and down 7, plotting a center right about here. And then my radius, I'm going to stretch out 9 units vertical above and below, and then 9 units to the left and the right. And I brought in this graph paper to make it fit, but it's obviously not perfect. And of course, a circle should be a little more round than that, but you get the idea. We've got a circle running through those points. There we go. Sketch it in there. It looks about like that. So when you plot the circle, you're going to need to plot just the center, and then you'll be traveling out some distance in any direction, 9 units, or the radius quantity of units. So that's how we deal with circles. Remember, a circle is just a very specific type of ellipse. So a circle is an ellipse, but not all ellipses are circles. As always, email me with any comments or questions.